Hey everyone, so now we're going to actually take a quick step back and we're going to re-talk about the quadratic formula and what happens when we actually allow for complex roots. You recall that we had two different ways of determining the roots, also known as the solutions, to any equation, in particular any quadratic equation. Recall that quadratic equation is something that has, x squared, x raised to the second power and then also equal to zero typically. We had two ways of finding those solutions. We've had the quadratic formula, and we also had completing the square. We're actually going to be looking at these two types of processes, methods of solving quadratic equations, but then how we end up getting some of the complex roots from them. Because if you recall, uh, whenever we use those, we always ended up with real roots. Now, if you're in class, you may have seen a few cases where we ended up having negative numbers underneath the radical. And I would normally say that, that means that it doesn't exist and we just ignore it. Well, now we're actually going to look at those specific cases where the underneath the radical will end up being negative. Recall that the quadratic formula was this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So just as a quick breakdown, the main idea is that when you have a formula, a quadratic formula, you always set it up into the form of a squared, a x squared plus bx plus c equals 0. So in this video, we're going to look at some of the questions where we're going to use the quadratic formula and getting these complex roots where we have a negative underneath the radical. Now, in the next video, we're going to look at completing the square. As I mentioned before, we're going to be constantly re-reviewing everything that we've done before. So make sure that you're not just forgetting everything that we talked about from the previous units, because we're going to be constantly bringing them back and looking at more and more scenarios with them. All right. So what I want you to do is work on this question. You are forced to use the quadratic formula. Do not use any other method. But determine the roots. So pause the video, work yourself. We'll go over in a second. All right, so for this first one, it's not written in proper form, so we have to move the 2x over to the other side. So when we subtract it, we end up getting x squared minus 2x plus 5 equals 0. Then we have to figure out what a, b, and c are equal to. So a is the term in front of the x squared. In this case, there's a 1 there. So a is going to be equal to 1. B is this middle term, which is negative 2. And c is going to be this last term, which is going to be 5. So we're going to use the quadratic formula. So it's negative b, which is negative 2. So negative negative 2 plus or minus the square root of b squared minus 4ac all over 2a. One thing to note is if you plug this into the calculator, make sure that you're putting parentheses around the negative 2, because if you do this, oh, hand slipped a bit. If you do negative 2 squared in the calculator, it will accidentally read it as negative 4, but that is not correct. You have to make sure you put parentheses to get rid of that negative. All right, so from here, we just kind of clean it up. Negative negative 2 is just a positive 2. Negative 2 squared is positive 4. And 4 times 1 times 5 is 20. So we get this. Do 4 minus 20, which gets us negative 16. This is an imaginary number, so we get rid of the negative by putting an I in front, and then we can see this is square root of 16, which is just 4. So we have 2 plus or minus 4i over 2. So dividing both terms by 2, we get that the two solutions are going to be 1 minus 2i and 1 plus 2i. All right. For number 2, I don't have to rewrite it. It's actually already in its proper form, so I just leave it as is. Again, we have our a term here, our b term, which is going to be the 1, and the c term. So using the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Cleaning this up, we end up getting negative 1 plus or minus 1 minus 48 all over 4. 1 minus 48 is negative 47. 47 is not a square root, and in fact, um, it doesn't have any factors that can be broken down any further. So all we can do is just pull out an I from this term to get rid of the negative under that square root. So our two solutions will actually be, actually I made a mistake. There should be a negative in front of these two terms. So negative 1/4 minus square root 47 over 4i, negative 1/4 plus square root 47 over 4 times I. All right. These are the independent practice questions. So pause the video, work itself, and we'll go over in a second. All right. So once again, I don't have to do anything special with this. I just do the A term, the B term, and the C term. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Cleaning things up, we get negative 8 plus or minus square root of 64 minus 100 over 2. 64 minus 100 is negative 36. 36 is a perfect square, so this becomes 6i. And then we end up getting, when we divide both terms by 2, we get negative 4 minus 3i and negative 4 plus 3i. For number 2, we actually do have to move the terms over again. So when I subtract the 6x and the 1 over, I get this. Once again, quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. I end up getting 6 plus or minus the square root of 36 minus 4 over 2. Note here that when I actually do the numbers under the radical, I'll actually get a positive number, radical 32. So this one is not going to be imaginary. This is going to be real number. Not every answer now will be complex. It's just that there's a chance it could be complex. So when I break up the rad 32, this could be written as 16 times 2, which gets us 4 rad 2, as shown here. So 6 plus or minus 4 rad 2 over 2. Dividing each term by 2, I end up getting 3 minus 2 rad 2 and 3 plus 2 rad 2. And that's pretty much it. Like I said, in the next video, we'll kind of go back to these quadratic equations and look at the other process, the completing the square. So make sure you kind of do a quick review of that if you forgot it. But that's pretty much it. If you have any questions, please let me know. Otherwise, I'll see you later. Good luck and have a great day.